we now demonstrate how to identify and resolve the multicollinearity issue for multiple regression. Let's look at this data set for liver regeneration rate. We are going to temporarily ignore the background about liver generation, but focus on the multicollinearity. So let's go to the regression directly. We are going to go to Analyze, Regression, and Linear. In this case, the liver regeneration rate will be the dependent variable, and we have 6 other independent variables, and we include them into the independent panel. Before we run the regression, we are going to change some options. Here, we are going to include the descriptives. This will give us information about the correlation. And we are going to click on the collinearity diagnostics as well. This will give us additional information about multicollinearity, and such as VIF values and variance proportions. We want to say continue, and we can run the regression now. In the output, we have the correlation information about dependent variable and 6 independent variables. We are going to focus on only the independent variables here and look at the values. We identify 2 big values larger than 0.7. The first one is V2 and V3, which has a value of 0.84. And the second one is 0.886 for V5 and V6. Okay, so we are going to keep this information to pay more attention to the pairs of V2, V3, and V5, V6. Now let's go down to the coefficient table. In this table, we can see the VIF values, and the V5 has the highest VIF value, 7.389, and the V6 has the second highest, the 6.018. The VIF value for V2 is 4.955, actually, which is borderline. So we are going to pay more attention to that as well. But before we make any decision, let's go to the collinearity diagnostics table. We look at the conditional index, and there's one value really gets our attention, and that is the conditional index for dimension 7, 47.3. This value is larger than 30, and so we definitely want to see the variance proportions for these variables. And we can see that the value for V5 is the largest, and the value for V6 is pretty big as well, larger than 0.8. So based on all this information, the VIF value and the correlation information, 0.88, VIF 7.3, the biggest for V5, and again, the variance proportion, the biggest for V5 again. So we can make a decision to remove V5 from our analysis at first. So let's go to Analyze, Regression, Linear. We are going to Independent Variable Panel. We are going to remove V5, okay? That is the one we don't want to include into our model now because of the multicollinearity issue. We are going to rerun the regression. Now let's go back to the coefficient table for the new model after removing V5 and look at the VIF value. Actually, all of them are below 5 now, although the value, VIF value for V2 is relatively large, but it is below 5, okay? So we are going to keep that in into our consideration. But if we look at the significance value, the p-value for the t-test of V2, we find that the p-value is very big, 0.924. Okay, so this is really a big concern for us. But before we make any decision, let's go to the last table, collinearity diagnostic table. Again, the conditional index actually has been improved because currently the highest value is 17.6. And the V6 give us the highest value of the variance proportion, 0.89. Because the VIF value for V6 is very small, it's 1.16. And we have already removed V5. So probably we don't want to remove V6 as well at this moment. So we can temporarily keep it over there. But let's go back to V2. This is VIF value is really a borderline, but the significance level for V2 is really low. It's 0.924 for the p-value. So we are kind of in a situation that we need to make a decision on whether to remove V2 or not. Given this situation is really kind of at the borderline, we can temporarily remove V2 and see what will happen to our new model. So let's go to analyze and regression and call the linear. We're going to remove V2 from the model. Okay, so we run the regression, we have a new model. Now let's look at the coefficients table about the VIF values. Actually, all VIF values are very close to 1 and below 5. So we probably don't have to address the multicollinearity issue anymore based on the VIF value. And the conditional index value actually are also all below 30. Although there's still one kind of the 5, the dimension 5 has a 15.658, which is borderline. And given that we have already removed V5, we can temporarily keep V6 here. Now let's try to compare these two models to see whether we should remove V2, okay? Because in previous model, we make a decision to remove V2 and look at the adjusted R-square. When we include V2 in the model, we have a 0.615. The adjusted R-square value is 0.615. Okay, now let's compare it to the second model. And the model, after we remove the V2, gives us an adjusted R-square value of 0.628. So this value is higher than the previous value. It means after we remove V2, the entire model quality improves. So this is a good sign, right? Now let's look at ANOVA. We can see that after we remove V2, the entire model is significant. It means we have a good goodness of fit for the model. So at this moment, multicollinearity issue is not a concern after we remove V2 and V5. At the same time, after we remove V2 and V5, we have the highest adjusted R-square value. This might justify that we probably should remove V2 and V5 from our multiple regression model. This demonstrates how we identify and resolve the multicollinearity issue in multiple regression. Thank you.